Hello everyone, I am Chandras Mishra from ABES Engineering College, Ghaziabad. In this lecture, I am going to discuss graph traversal. So here we'll discuss what is graph traversal, and we'll see breadth first search BFS algorithm to traverse the graph. So basically, traversing every node of a graph and printing them is called traversal of the graph. So basically here we have two algorithms for the traversal of graph, which is BFS, that is also the full form of BFS is breadth first search, and another one is TFS. So first we'll discuss BFS. So let's begin with BFS. Suppose we have a graph like this. This is the graph like this. This is a graph given to us, and we want to traverse this all the nodes of this graph. So we'll use BFS algorithm for this purpose. Suppose the uh, name of these vertices are A, B, C, D, and this is E. So name of the nodes of this graph is A, B, C, D, and E. So basically, what are the steps involved in the VFS is first we'll create a queue, because what we are going to do, first of all, we will traverse all the uh, adjacent nodes of the starting vertex. Uh, that is the all the neighbors of the starting vertex, and then we will move in the next level. So for this purpose, we need a data structure called queue. We'll use queue data structure for this, because this queue is FCFS, first come first serve, or we can also say first in first out FIFO. So we'll use this queue data structure to implement BFS. Okay. So for this, what we'll do, we will create another array which is called visited array. So that will track the status of all the vertex, whether this vertex is visited or not visited. So we'll create one visited array and another empty queue. So suppose this is the visited array. Okay, this is our visited array. Here we have dedicated slots for each vertex. Like this is for A, this is for B, C, D, and E. So here we have in this, this is the visited array. We have given name it as visited array. And the status of all the vertices in the visited array is set to false in the beginning. So we'll set status of all the vertices as false. Okay. And we'll have one queue. This is the queue. So initially this queue is empty. This is the queue, and the queue is empty in the beginning. So in the starting, suppose we are going to start from this vertex A. So we'll just put this A vertex in the queue and mark this A vertex as visited. Okay, so status of this A vertex will be true in this visited array. Okay. Now, after doing this, what we'll do, we'll find out all the adjacent vertex of A. So we already know what is the adjacent vertex. All the vertices that are directly connected to a vertex is called adjacent vertex of that particular vertex. So rather than finding adjacent vertex of each vertex every time, we can create an adjacency list for all the vertex. So let me write adjacency list of the vertex. So here we have A, B, C, D, and E. So we'll write adjacency list of A. So all the vertex that are directly connected to A is B and D. So B and D. Adjacency list for B will be A, D, C, and E. So A, D, C, and E. Because we can see here B is directly connected with A, D, C, and E also. What will be the adjacency list of C? Adjacency list of C is D, E, and E. So we'll write B, D, and E. Adjacency list of D is A, B, and C. A, B, and C. Adjacency list of E is B and C. So here we will write B and C. Now come to this point. So what are the vertices that are adjacent to A? We can directly find out from A, that is B and D. So we'll just put B and D in this queue, B and D in this queue, and mark the status of these B and D, this B and D as true in the visited array. So B is also true and D is also true. And now front, we know the front is pointing to the first element of the queue, and the rear is pointing to the last element of this array. Now rear is here. And now what we have done, we have just popped out this A from the queue and print it or added it on in the BFS list. So A is here. Okay. And in the graph, we can see we can mark it as shaded. Now the front is here. Now we'll again repeat this process. We'll find out the adjacent vertex of B. So adjacent vertex of B is A, D, C, and E. So what we'll do, we'll add all the vertices in this queue that are not visited. It means their status is false. We'll add all the vertex from the adjacency list for which the status is false. So we'll do this one by one. So A is already visited. So you can see here the status is true. Will not add in this queue. Now come to D. The status of D is also true. So we will not add in this queue. The status of C. C is false. So we'll mark C as true and add this C into the queue. Now come to E. The status of E is also false, so we'll add E in this queue and mark the status of E as true. Okay. Now we'll pop this B from the queue and add this B to the BFS list, and now change this B in the graph. Now again the front is here. The front node is D. Now come to D. So what are the adjacent vertex of D? So come to here A, B, and C, and the status of A, B, and C is already true. So we will not add anyone, and we will just pop this D from the queue and add it to the BFS, and just change this color of the. We'll just change the status here also in the graph. Now our front is here. We'll come to C. Now we'll see the status of. We'll find the adjacent vertex of C. We can directly get it from the adjacency list. B, D, and E. We'll see the status of B, D, and E one by one. The status of B is already true. The status of D is already true, and status of C is status of E is also true. So we'll not add any new node in the queue, and now we'll pop C from this, and we'll add C here in the BFS, and marks added in the graph. Now come to the uh, E, this vertex. We'll find out the adjacent vertex of E, that is B and C, and we can see here B and C are already visited, so we'll not add it in the queue, and just pop this E from the queue, and we'll add this in the BFS list, and we will mark shaded in the graph also. Now we'll stop this process because now you can see the queue is empty. So we'll repeat this process until the queue is not empty. Whenever the queue is empty, we'll stop this process, and our BFS is A, B, D, C, and E. Now let us see the algorithm for this. This is the algorithm. The first step of the algorithm is create an array visited that we have created, create an empty queue named as queue. Now mark visited v equals to true because we have started, v is the source node from where we are going to start our BFS graph traversal. So first, in the first step, we'll mark v as the true and enqueue that v in the queue. So we have just enqueued, inserted v in the queue. And after this, what we will do, we will repeat this process until the queue is not empty. We'll repeat this process until the queue is not empty. What we'll do, we'll delete one element from the queue, and we'll find all the adjacent vertices v for all adjacent vertices of v, all adjacent vertices v of u. We'll check whether this v is visited or not. If v is not visited, then enqueue, or we can say insert that v in the queue and mark this v as true. And now we'll do all this process repeatedly. So this is the algorithm for the BFS. Now come to the point, what will be the complexity of BFS? So we can say the complexity of this will be the number of vertices, or we can say plus edges, whatever we are having more will be the complexity of this worst case complexity of the BFS. Worst case complexity of this BFS. And now, what will be the space complexity for this? So, in the worst case, we can have one visited array and queue. So, we can say order of n will be the space complexity also will use. Or we can say order of n is the order of v, that is the number of vertex in the graph. So, order of v, we can say. This will be the space complexity for this graph traversal algorithm. These are the references for this lecture. Thank you for listening.